Day geometry, we are going over 23. Mornings for you. Going over CO23, triangle congruence in various contexts. This is setting up for a massive yet exciting PO24. PO24, we're going back to proofs, and we are proving triangles are congruent. It is a four-parter. Look at that. 4 parts of PO24. But before we get there, we have to talk about corresponding parts. Now, we know that the word corresponding, at least with angles, talks about angles in the same location, Liesl. Corresponding parts are similar in that they are the parts of two figures that are in the same location. Okay? The parts of two figures that are in the same location, or they have a relationship. Okay? Your first introduction to these was back in pre-algebra, actually. CO38. Did you have?
We didn't
You wouldn't have, no. But so skipping the congruency statement here and going down to this figure here, notice it's full of markings, right? And we know that these little tick marks mean that the side lengths are congruent. We know the arcs mean the angles are congruent. So let's just look at side JK here. What side in the other triangle corresponds? Joey, warning for you, you're second here. Let's rein it in. What side on that other triangle corresponds with JK? I mean, it's in the same location. It's got a relationship. Alexis? Side ST. Now, technically, Vince, warning for you, the proper way to say this would be side TS. Because if I label this JK, notice I'm starting at point J, which is that 3-arced angle, and ending at point K, which is a single arced angle. I'd have to go the same direction on the second figure, okay? So it wouldn't be quite correct to say that JK is congruent to ST, because ST is going the other direction. I have to go from the triple arc to the single arc, and so instead of ST, it should be TS, okay? Because TS also goes from the triple arc to the single arc, all right? What angle corresponds with angle K? Angle K is congruent to angle S, and you know that because? Right? Because they're the same location, they have that relationship of being congruent, right? So that's what corresponding parts are all about. And basically, a congruency statement is a statement naming two figures congruent. Yes, I am recording. Okay. A statement naming two figures congruent, identifying corresponding parts. Okay. A statement naming two figures congruent, identifying corresponding parts. Again, a statement naming two figures congruent, identifying corresponding parts. So if I wanted to name those two triangles and write a congruency statement, okay, I would not want to write triangle KLJ is congruent to triangle RTS. Why would that be incorrect? Incorrect. Kylie? I didn't match up corresponding parts, right? Angle K, we know, corresponds with angle S. So if I start with angle K in my first part of this statement, I have to start with angle S in the second part, right? And then if I go to angle L seconds, what angle should be seconds in the other part of that statement? R. because L and R correspond. They're both a double arced angle. If I end with angle J in the first part of the statement, what angle do I end with in the second part? Right? T, Q, what? T, because T is that triple arc. I asked you to move over to your spot once, Jack. No, you're not. You're sitting over there. There should be a full seat of empty between you and the next person. Okay? So this would be incorrect, right? Because it does not match up those corresponding parts. It would be correct to say that angle KLJ is congruent to angle SRT. Okay? You don't have to start with the single arced angle either. If you wanted to start with triangle LJK and name it congruent to triangle RTS, that's okay too. Okay, because in the statement you've matched up those corresponding parts. You've matched up L with R, J with T, K with S. It doesn't matter which one comes first, as long as your second one is in the same order. Okay? Yeah. Yes, thank you. Sorry. I should put a triangle here. This was triangle SRT, and this was triangle RTS. I got so excited writing down those congruency statements. I felt, well, arguably the most important part. Yeah, triangle. Questions on that? Just a labeling piece. When we get to proofs, this is going to become very important because we're going to be proving and naming corresponding parts, sides, angles. And so knowing how to do it is just going to be a proof thing. You'll get plenty of practice with it soon. But here's your intro to it. Are we okay? No? Question, Max. Oh, haha. Anything else? Any other jokes? Okay. Third angles theorem. We get another theorem to add to our toolbox because we always want to be building on to that toolbox. Okay. Our toolbox is our box of postulates and theorems and properties and definitions that when we're solving proofs, we can say, how can I defend this? And we look in our toolbox, we pull out the best theorem, the best postulate, the best definition, and we use it. You should not have done that because we are not going away from the postulates and the theorems. The third angles theorem says that if two pairs of corresponding angles in two triangles are congruent, okay? This is going to be an if-then statement because we got that if there. If two pairs of corresponding angles in two triangles are congruent, then the third pair is also congruent. Okay? If two pairs of corresponding angles in two triangles are congruent, then the third pair is also congruent. Remember when I write these things out, what we know, wait, what was my color coordination? What we use is green, what we conclude is in red. Is that it or is that the other way around? I feel like what we knew was in red, then we could go with it because concluding, I think that was my thought process. So, if we have two triangles, draw them here. They look kind of congruent, I guess. But if we know that two pairs of corresponding angles are congruent, so I'm going to mark these congruent here, right? It does. If we know that two pairs of corresponding angles are congruent, the third angles theorem tells us that this third pair is also congruent. So basically, if you know that two pairs of two triangles are congruent, you know the third pair is also. How can you just verbally defend that statement? Why does that make sense? It does sound very, very, very smart. Yeah.
Because all triangles equal 180 degrees, so there's only going to be one.
Exactly. Because all triangles, the interior angles have to sum to 180. Whatever this measure sums to, the known congruent angles, there's only a certain number of degrees left, and it has to be the same, right? If this is 60 and 70, That's 130. There's only 50 degrees left to use in both of the triangles. Only one angle, 50 degrees. They both got to be 50. Okay. This one is actually going to become very useful for us. It basically allows us to only have to prove that two angles are congruent in order to know that the third pair is congruent as well. So that's going to be kind of an important one. Okay. Down below it says in the diagram, DEFG is congruent to SPQR. The importance of a congruency statement is, like I said, it gives you those corresponding parts. You can kind of probably tell that those two shapes are not the same position, right? The second one's been flipped or turned or rotated or whatever. But what this tells you is that, angle D corresponds with and is congruent to angle S, right? Because of the first letter of each statement. So when I ask you to find angle S down below here, if you know what angle D is, because you know D corresponds with S and D is 102, you know S is 102, right? Because the two figures are congruent, right? Therefore, their corresponding parts will be congruent as well. And because of that position of D and S in the congruency statement, you know that they are two angles that correspond. So if you know one's 102, the other one's going to be 102 as well. Okay. So just go ahead and kind of in your tables here, work through the other 5 questions, knowing what matches up with what. Set up some equations, use some logic. You don't have to write any proofs, but go ahead and solve for those other pieces, and we'll convene shortly. Here we go. 3, 2, 1. You are quiet. Joey, what is the value of x? And how'd you go with that? Back corner. Shh. Up here.
8 times 2 is 16, and minus 4 is 8.
How'd you know that QR corresponded with GF here?
Because if you flip it around, it's on the bottom.
If you flip it around, also the roadmap, the congruency statement, QR is the third and fourth letters there. FG, the third and fourth letters there. So you know that those two sides will correspond. You are correct. X is 8.
Yes.
Hey, folks, we're back recording, so you need to be quiet. If you can't be quiet, then please leave, because I don't want to have to stop again. Okay. The value of y. Alexis, how'd you find it?
I did 6y + 8 = 68, and then I subtracted 8, and then divided 6 to what I got, and I got 10.
So how'd you know that 6y plus x was equivalent to 68? And how do you know that? I'd rather hear Aiden. Anthony, warning for you. It's because angle Q and angle F are both the third letters in their congruency statement. And so you know that they correspond. Jack, turn around, please. So you know that they correspond, therefore they are congruent angles. What is the measure of angle R? Quickly, anybody? 84. Angle R corresponds with G. Side PS. Thank you. Side PS is 8, corresponds with side DE. And angle P. Folks, raise your hand. Arlene. Jack, be quiet and listen, and I'm sure you'll hear. Yep. P corresponds with E. You know that they're both the second letter in each of their statements. There are 360 degrees in a quadrilateral. And so once you add up 102, 60, and 84, there's 106 degrees left to get to that 360. It's very important to look at that congruency statement. P and D look like they might be the same, but they're not. 106. All right, no homework for tomorrow. That's how you math. Like and subscribe. Have a great day, folks.